I wanted to make this presentation on JavaScript testing, basically covering development patterns that I frequently use and testing best practices. I felt I wanted to capture this in a video so that I can easily share it with other developers that work for me and other developers that I work with so that they can understand where I'm coming from and the approach I take and the typical patterns I use. When you become a senior developer, you focus much more on the patterns than the code, or much more on the patterns than any particular application or business logic, because these patterns are what are remain consistent from project to project. So if you can focus on the right patterns and the right testing best practices, these will empower you throughout your career, and it doesn't really matter who you're working for or what the specific project is. These are the valuable lessons that continue to pay off over the long term. So I created a repository to just illustrate some of these concepts I'm going to cover in this video. And so you can pull that up by going to github.com/christroutner/testing examples, or a testing example. And I've got a README that covers with some links and covers the main points here. I'll stay at a high level at first, and then I'll dive in. As I progress, I'll get into deeper and deeper into the code. But just to stay at a high level, some of the main concepts is using this new class, or I guess I shouldn't say new because it was published in 2015 and now it's 2019, so it's been 4 years. But it relies on this class way of creating libraries. It's basically syntactical sugar for the original JavaScript prototype function, but there's a lot of value in this syntactical sugar, and mostly I'll be focusing on this using the class, using JavaScript classes as a way to make unit testing easier and really just to make everything easier. And I'm also want to give a shout out to test-driven development, usually called TDD. And in particular, there's one article that has been incredibly inspiring to me over the years. Is this article by Matthew Kane Parker on why TDD. But a lot of people, if you ever hear the phrase like "go fast forever," he really talked about that. Go fast forever, and he gives a really excellent real-life pragmatic examples of different development teams, and he always comes back to these curves where most people are on the curve on the left, where you start out fast, you add features fast, and you can move fast, but you acquire technical debt and add complexity, and so it seems like you get results really fast, but then your whole team gets bogged down by technical debt and complexity, and that speed is what kills projects, or that initial rush of speed and the lack of managing technical debt. And so the whole point of test-driven development is to be able to release new features while maintaining confidence that the new features are not breaking old features. And so this article really goes into depth on that. I link to it from the README here. So I really highly encourage everybody to read that and check it out and really internalize those lessons. I'm going to give a more practical, hands-on, but everything I'm going to show is very much in line with the higher level principles that he talks about in that article. So let me just dive into the code. If you clone this repository and then run npm install, which I already ran, if we look at the package.json file, which is where you should start anytime you're looking at a node.js JavaScript program, you'll see that I've got 3 development dependencies Mocha is the testing library. Chai is the assertion library, which goes with Mocha. Two very popular. This is the most popular testing libraries in Node.js JavaScript world. And then Sinin is used for mocking for unit tests, and I'll talk about that more in a minute. And then I only have this one dependency, which is BCH.js. Now this is a library for interacting with the Bitcoin Cash blockchain. This is a fork of Bitbox. But if you are unfamiliar with Bitbox or Bitcoin Cash or any of that, don't let that stop you. This is really superfluous. What I really needed was just an external library making network calls so that I could illustrate how to mock external calls in this example. So this video doesn't have anything to do directly with Bitcoin Cash. It's just I'm just using it. You could replace this with a database or any other type of REST API or any other type of external call that a program would make. So if we go into the index file, it's a very, very simple program. I give it a Bitcoin Cash address, and then I'm requesting data from the Bitcoin Cash blockchain on that address, and I display it to the screen. So if we run it with npm start, I should also point out I have 3 scripts here. So npm start will just run the index.js file, pretty typical. npm test will run the unit tests, and then test::integration will run the integration test. And this is a common pattern that I follow and that a lot of people in the industry follow by doing the test and the test integration and breaking them up separately that way. So if I run start, what it's doing is it's just reporting the Bitcoin Cash address to the console, and then it's going out and talking to an indexer that is getting data on this address. So it returns a BCH data object with 2 properties, balance and UTXOs. The balance contains information about the address, and UTXOs, these are what you actually spend in Bitcoin. So this is pretty critical information if you're going to do transactions with Bitcoin Cash. But again, I don't want to focus on the Bitcoin Cash specific stuff. Basically, the point is the program's going out and getting data over the internet and bringing it back and presenting it. That's the main purpose of this example program. And what I have here is a utility library, and this would typically be like business logic, or most programs have a utility library, which is typically in the lib folder and named util, that does just like really basic utility functions to support the program. So if we go into that file, you can see right here, this is where I'm calling the external BCH.js library. And a few main concepts that I want to, if we go back to index, that I want to cover is in this library file, you can see that here's the class name that I was talking about. So it's creating a new class called utillib, and the typical structure is to use a capital letter to indicate that it is a class, rather than a lowercase, which is to indicate that it is a instance of a class. So in this example, in the main index file, you can see again capital letter to indicate that it's a class, and then I call the new keyword to instantiate the class into mylib, and then this is what I actually end up calling in the program. And again, inside the utility library, you can see that same pattern here with calling BCH.js when I actually add the library in, and then down here I am instantiating that class, and then it's the instance that I use in the program. So another pattern with these classes that's commonly used is this underscore. Underscores typically indicates that it's private, it's not publicly exposed. And so one of the things that I have done, it's kind of an oxymoron, but I call them locally global variables. And one pattern I commonly use is I will set this underscore this is a real, the keyword this is a really important concept in JavaScript. I'm not going to go into detail here, but because it's it's highly contextual and the context changes frequently. This is why I create this underscore this, which is a global variable as far as this library is concerned, and I assign it in the constructor so that further on I can just call this, and I don't have to worry about the context of the this keyword. If I call underscore this, I know that I'm calling the instance of the class, and that's what I want to call. So this is another common pattern. In general, underscores mean like local functions or private functions, and in particular, the underscore this is what I use to, so I don't have to worry about the local context of this keyword. I can call this underscore this, and I know that I'm talking to the instance of the class. Another important pattern that I follow is each function is wrapped in a try-catch statement, and that allows thrown errors to bubble up to the top level function. And it gives every function along the way an opportunity to handle the exception. So you can see that here in the main program. So this is the main function, and I call it here to actually like kick off the program and start it. And so this main function is written here, and this is the only place where you'll see console error typically, where I'm just saying here's the error and here's the raw error. I'm going to write it out to the display, and this will, following this pattern, will eliminate the really annoying messages that Node.js throws about unhandled promises. A lot of people have seen that, and it's not so obvious what to do to fix that. This is what you do to fix it. You just, whatever your main function is, it kicks off the whole thing. You wrap it in a try-catch, and you can just write your error, and that'll get rid of that unhandled promise annoying thing that Node.js loves to display on the console. And then again, when we go into the library, you see this try and catch statements, and typically this throw error is the only thing that needs to go in there unless you want to do some specific error handling. But what I will typically do is just write a one-liner. Notice I'm not including anything about the error object. I'm just saying, hey, this error happened in this file and in this function within that file. And what happens is, if there were multiple levels of subfunctions, and I did this in each one, you'll see a chain like, error started here, then it went to there, then it went to there, and then it came up to the main function, and the main function handled it. So when you're debugging, you can see the whole chain of the error as it bubbles up. You can see each level. And that really helps with debugging. Now, in production, I wouldn't write things like this to the console. This would be handled by a logging application like Winston. So I would replace this part with I usually instantiate Winston as wlogger, and it would go like that, or debug, or error. So that's how I would handle that. But when I'm just writing really simple applications, there's nothing wrong with doing console log. Okay, so try-catch statements. Every function should have a try-catch statement. When I am reviewing other people's code, that's one of my, I guess you could call it a pet peeve, except it's not really a pet peeve because this really is a best practice, that everything should be written in try-catch. If it's not, you should have a really, really good reason for not wrapping everything in try-catch statements. Another typical pattern is, and I'll usually call it out in the comments, is the very top of any function, once you enter the try statement, is a validation section where it's just simply validating the input. Now, a lot of people like TypeScript for this reason, because it enforces typing, and they think that they can get rid of this part, but you really can't. TypeScript's a step in the right direction, but it doesn't eliminate properly validating your input. So whether you use TypeScript or not, you still should validate your input. And so in this case, it's expecting address to be a string. If it's not a string, it throws an error. And this is a really simple example. If this was an actual program I was writing for Bitcoin Cash, I would do more intense validation. I would like make sure that the address is the right length, that it starts with the right characters, and I would do a more intense validation here. And when you're doing really complex stuff and you really need a complex validation, it's fine to just create another subfunction that does the validation for you. So you would just have one line like validate input, and then you would pass all your input variables into it. And then if there's anything wrong, it would throw an error. And so yeah, just another pattern to be aware of, that typically wrap everything in try catch, and at the very top is a validation. That's usually what I look for. Another, and this is really important, this is like one of the main points I want someone watching this to take away, is that the way that the JavaScript classes help with testing, writing unit tests, is that you can embed external dependencies into this object. So here you can see I have this external dependency, which is bchjs, and I am saying this.bchjs equals bchjs. So down here in the functions inside the class, I'm not calling bchjs directly. I'm calling it through the this keyword, and I'll show in a minute why this is valuable. But just keep in mind, this is one of the biggest things that you should take away from the video. Okay. So I guess with that, let's move into the tests. Usually I will start integration test and the unit test. And what separates an integration test from a unit test is that unit tests do not make external calls. There's other ways to define unit tests, but the biggest difference between a unit test and an integration test is that an integration test is making live network calls. It's talking to a live database, it's making calls over the internet, and it's testing that basically the real life system is working. Unit tests do not, I will usually bend the rules when it comes to databases, but unit tests do not make live network calls. That's a rule I never violate. And in this case, the whole function the whole program's making a live network call to the Bitcoin Cash blockchain. So that's why I use that as an example. So if I see a unit test, so typically when I'm running, so let me just run the tests real quick, the unit tests. So there they passed. I'll go more into depth in this, but one thing I will typically do when testing unit tests is I will turn off my Wi-Fi. And if any of them fails, that tells me immediately that they're making external network calls, and they shouldn't be doing that. So if you are wondering if your unit test is an actual unit test, that's a really great way to verify. If you turn off your Wi-Fi and you run your unit tests and any of them fail, just because you're not connected to the internet, that means that your tests are not properly mocked. And do you notice how fast that is? I mean, that's the thing. Like, I could have hundreds of tests, and if they're properly mocked, they're just going to be super fast, and that's what unit tests should be, and that's one of the values of mocking. And then integration tests test the actual live network call. So let me explore the integration tests real quickly. Basically, this is the setup of a typical Mocha test, and you'll see here in the layout, I have a test directory, and then within the test directory, I have an integration and a unit directory, and then within the unit directory, I have a mocks directory that contains my mock files, and I'll go more into depth in a minute. I'm going to focus just on the integration directory and the integration test. So as I said before, this is using Mocha. If you try and run this with Node, it'll error out. So if we look at the scripts, it's calling Mocha instead of Node. So that's kind of implicit here. And then Chai is the assertion library, and really all I'm using is the assertion library in Chai. There are other parts to Chai that I'm not using. I instantiate the unit under test, which is the util-lib library. This test library only has one test case. So you typically start with describe, like which will encompass everything and calls out the file that you're testing. And then if I had additional functions inside this library, other than just get BCH data, each one would have its own describe block. And then inside of each describe block is a test case, and that starts with it. And so this only has one test case. It should get BCH data on an address. So here I give it an address, I call the library on that address, and then I'm asserting that the data coming back fits certain values. So I'm asserting that it has a balance property and that it has a UTXOs property. And then within that UTXOs property, I'm asserting that the UTXOs property is an array. And then within the first entry of that array, I'm asserting that it has a TXID property, a vout property, and a Satoshi's property. And one of the things I want to call out here is that I'm focusing on the properties and the structure and not the values. So again, if we look at the output of the program, you can see here the UTXOs property is indeed an array, and it has a TXID and vout and Satoshi's property. Now these are actually like the critical pieces of information for doing something with Bitcoin Cash, and that's why I focus on these. But don't get bogged down by that. The point is that when you run these tests, you should have an idea ahead of time of what is the most important thing. And again, like I wouldn't want to test the value of this TXID property. I wouldn't want to test, how many Satoshis are in there, because that data can change. I could look at a different address and that data is going to change. Those values are going to change. But the structure of the properties existing and it being an array, and then the properties existing inside the first element of that array, those should be consistent from address to address. And so that's why I'm testing those. So I'm focusing on properties and structure, not on value. So that's another kind of important best practice and pattern for testing, so that your tests aren't fragile. Okay, so now let's move into the unit testing. So typically when I'm writing an application, I will follow a test-driven development practice, which is the red-green refactor, where I will sort of kind of just roughly pseudocode a function I'm creating, and then I'll create the unit test. And just like one very basic thing that I know is going to fail, and I'll watch it fail. The important thing at that is not that it passes, it's that you can call this function over here from this file over here. That's like the first step to writing a test. And again, I start with the integration test, because mocking is something I do later, after I get the thing in the real world working the way it should. And so basically, this is how I would start the test. I would follow this basic pattern that never changes. Here's my input, here's my output, and then I would write the output to the screen, and that would be my test. And then I would add my assertions, and then that's the test case. That test case is done. So unit testing is a different story, because in unit testing, like I said, you don't want to make live network calls, and there's also other tests that will only exist in a unit test and really don't have any need to exist in an integration test. So an example of that is this test case right here, where I'm testing that it should throw an error if the address is not a string. So that gets back to this validation part of the function. Is I want to test this. I want to have a test that makes sure that this is in fact doing what I expect it to be doing. And so that's this test case right here. So it doesn't have any mocking it, because it doesn't need it, because this part is not going to execute, because it's going to stop right here and throw an error. And this is also an example of a negative test case. So here that I showed in the integration test, this is an example of a positive test case. We're expecting this to not throw an error, and we're expecting to get data back, and then we're going to assert on that data, and that's a positive thing. Everything completed appropriately. In a negative test case, you're expecting it to throw an error. If it passes without throwing an error, that's a failure. And so that's this line here. I'm calling assert equal true false, which is going to fail because true is never equal to false. And I even just added this little piece of data there saying unexpected result. So I am not expecting this line to execute. If it does, it'll fail the test, and that's what it should do. So here I'm assigning a number to address, which I know will make the error to get thrown, and then I'm calling that function, and then the catch statement is handling it, and I'm asserting that the error message includes address must be a string, which is what I'm throwing right here. So this is a negative test case, and typically I'll do my negative test cases in front of my positive test cases. Doesn't always have to be like that, but in general that's the pattern I follow, because the validation typically comes at the beginning of a function, and so that's why the negative test cases typically come first. Okay, so now if we get down here to the second test case, this is almost identical. If you ignore this part and you just focus on this part, this is identical to the integration test. It should get BCH data on an address. It should get BCH data on an address. So it's the same test. The difference is right here in the mocking. And let me take a second to talk about that. For mocking, so first of all, what a mock is that it replaces instead of making a network call, it replaces that network call with data that it has locally, so that the network call never gets made. That's the point of the mock, and that's what makes unit tests so fast. And so if we look at this util mocks mocking library, right here, you can see I have a mock balance and I have a mock UTXOs, and this is the same data that comes back here. And so I'm using Sinin is my mocking library. It's very common, and I link to it here in the README. You can go to the Sinin stubs article. This is a great article. I always find myself coming back here and reading this page every couple days, because mocking is a very deep thing. It can get pretty deep, and there's a lot of different ways to do it. And in my view, and in a lot of professional JavaScript developers' view, Sinin is probably one of the best and most flexible mocking libraries, particularly if you use it this way. So what's happening here in the unit test is at the beginning I create this global sandbox variable. Before every test case, it creates a new sandbox, and then after every test case, it restores a sandbox. So this just ensures that any stubs that I create do not bleed over from one test case to the other. Every time I run a test case, it's happening in its own sandbox, and anything that happened in a previous test won't affect the test I'm running. So that's what the sandbox and everything is. So it's actually Sinin create sandbox. So when I actually do my stubbing down here, I call that sandbox variable. And what I'm doing is I'm stubbing out the balance call on BCH.js. Now this is getting back to, remember when I said like this about the most important point in the video? That's what this is. So because I'm calling BCH.js library, which is embedded in the this folder, when I instantiate the library over here, I can reach into it and I can mock out that external dependency. And that's what I'm doing right here, is I'm replacing that balance function right here. I'm replacing this, so when it calls this, it's not going to call that actual function. It's going to get replaced with my mock, and it's going to be and then when it comes back, it's a promise, so it's going to resolve. Otherwise I would use return here. It's going to resolve into this object here, which is my mock data, You can see I included that right here, mock data, util mocks, and mock balance. So it's going to return this data. And so that's the mock. Instead of making a live network call, it's going to call a different function that returns this hard-coded data that I have in that file. And that's the mock. And that's like, this is such an important concept of mocking. And another really important concept is I'm not mocking the output. I'm mocking the input. So I'm not mocking this data. This is the output of the program. I am mocking this function, the data returned by this function, and then later on I would do more data processing. In this particular example, I'm just putting it inside an object and returning that object. But that's an important concept that I see a lot of developers stumble on, is when you're mocking the inputs to the function. You're not mocking the outputs to the function. I see a lot of developers try and mock the outputs, and then they wonder why their mocks don't work. So yeah, just an important thing to keep in mind. So because this function, it calls a balance and then it calls get UTXOs, I have to create two mocks for two separate functions, and I'm returning two different chunks of data, which are captured here and here. So like I covered, everything else past this point is identical to the integration test. Really the only difference is this test is not making live network calls, and the other test is making live network calls. So again, here is the program running. That's the output of the program, balance and UTXOs. If I run the integration test, it's just running one test that is making sure the data coming back is valid. If I run the unit tests, it's running two tests. It's running this test, which is the negative test, asserting that it threw an error appropriately, and then it's running this regular test case, this positive test case, that's just making sure that the function's behaving the way we expect it to behave. So this is an example of a test case that really only belongs in a unit test, and it just really doesn't belong in an integration test. We could test it, but but it would just be redundant. And again, unit tests do not make network calls. That's one of the important things about unit tests, and so we prevent that with stubbing. Okay, so that covers everything I wanted to cover. A little long, a little dry, but if you internalize these development patterns, this is going to make your code easier to read. It's going to make it much more reliable. You'll be able to follow these concepts in this article and be able to go fast forever and be able to churn out bug-free code and have confidence that new features you add to your product do not put previous features at risk.